Hello everyone, welcome back to the session. Good morning, good afternoon, good evening. Greetings of the day to all of you. I hope you all are doing well. We will start in a couple of minutes. Let's wait for the other participants also to join in, and then we will begin the class. Meanwhile, I'm sharing my screen. Let me know once you can see it. Perfect. All right, just 2 more minutes and then we will begin with the session. All right, so let's begin the class. Hello everyone again. Welcome back to the training. I hope you all are doing well. Let's get started. In the session yesterday, we tried understanding some basics of networking and spoke about fundamental concepts. We tried understanding various things in the session yesterday. So we'll quickly go through them again. We discussed about, first of all, how the certification works, then spoke about the content, then discussed why do we actually need networks, the different types of networks on the basis of geographical area. Then we discussed about the components of the networks, which can be comprised of network devices, the media, the network services, then spoke about the different types of communication, different types of topologies, types of cables, and so on. Yeah. Then also discussed what is the straight through cable, what is the crossover cable, and discussed the technology auto MDIX and the different types of fiber optic cables. Before getting started with the day 2, I quickly want to ask you guys a couple of questions, which you can try to answer in the Telegram group, and then we'll be moving ahead. So the very first question for you all is, if I wish to connect a switch with another switch, and we are assuming auto MDIX is not there, so what type of cable would be appropriate to connect these two devices? We have got the responses crossover. We'll require a crossover cable as these are two same category devices, right? Let's say I wish to connect my PC with a switch. Now, which type of cable shall be used? Will require a straight through cable as they belong to different categories. So when we have devices from same category, we'll go for the crossover cable. When we have the devices from different categories, we'll go for the straight through cable. Today, we are going to explore a bit of details related to the IP addresses. We'll try understanding how IP addresses work. What are the different classes of IP addresses? What are the different uh, types of IP addresses, right? So guys, when we talk about IP addresses are available in two versions, IP version 4 and IP version 6. IP version 4 and IP version 6 basically are there. And we all know that we had to switch to IP version 6 because we basically utilized the complete address space of IP version 4. Now, still, IP version 4 is the most common version that we see getting used in the networking domain. It's still there. There are still devices which are still based on IP version 4, right? And the protocol operates at layer 3. What is this layer 3? We'll get into the detail of that when we discuss the networking model, OSI and TCP/IP later on. As of now, just understand that IP operates at layer 3, which is the network layer, and takes care of basically routing the packets from one network to the other network. This IP addresses are assigned by an organization called INA. INA stands for Internet Assigned Numbers Authority. INA assigns the IP addresses to something called as RIR. RIR stands for Regional Internet Registry. From these regional registries, the blocks of IP addresses are assigned further to ISPs. What are ISP? ISP stands for Internet Service Provider. From these Internet Service Provider, finally we get the IP address. The customers or the users or companies, when they want a public IP, they go to the internet service provider and they are responsible for assigning it to the end users or the company or the customers, right? Now, if we have a quick look on the website of INA, we can see that it describes itself by saying we are responsible for global coordination of Internet Protocol addressing system, as well as autonomous system numbers for routing internet traffic. What does that mean? That simply means that this organization or this authority is responsible for managing the complete allotment of IP addresses all over the world. Okay. Then it tells you that currently there are two types of IP addresses in active use, IP version 4 and IP version 6. IP version 4 was initially deployed. Yeah, IP version 4 was initially deployed on 1st January 1983 and is still the most commonly used version, like we discussed. Then IP version 4 are 32-bit numbers often expressed as 4 octets in dotted decimal notation. Deployment of IPv6 began in 1999 and it is a 128-bit number having the hexadecimal string looking like this. IP version 4 looks like this. Keeping that in mind, we'll proceed ahead and we'll try to look at the different regional registries which are there for different regions. First, we have it for Africa region with the name as Afrinic. Then we have it for Asia Pacific region with the name as APNIC. Canada, USA, and Caribbean islands, ARIN. Latin America and some Caribbean islands, LACNIC. Europe, Middle East, and Central Asia, RIPE NCC. So the IP address management, the IP address allotment is being done by these different regional registries. Depending upon the areas, a company would contact their appropriate ISPs, and ISPs get this from regional registries. Make sense? And like we discussed, there are two versions, IP version number 4, which is of 4 octet, having a size of 32 bits. And IP version 6, having the size of 128 bits. IP version 4 is represented in dotted decimal form, whereas IP version 6 is represented in hexadecimal form. If I give you an example of IP version 4, it looks something like this, 192.168, let's say 5.10, okay? In this IP address, there are 4 octets. Each value or each group here is called as octet. And each octet is made up of how many bits? 8 bits. So my IP address has 4 octets. So 4 multiplied by 8 means 32 bits in total. Then when IP version 4 was introduced, it was divided in 5 classes. Let's understand what are these 5 classes. We have got a class A, class B, class C, class D, and class E for my IPv4 addresses. Class A ranges from 0 to 127, out of which 0 is reserved for default IP. It's reserved as default IP. When there is no IP assigned on the computer or the PC or the workstation, it picks up the IP as 0.0.0.0. So that's what it is reserved for. And 127 is reserved as loopback IP. Loopback IP is used to check the connectivity with the networking model or the TCP IP stack, which in detail is something we are going to discuss later. Okay, as of now, just understand these are reserved for both of the given purposes. So that makes the actual range of class A, the actual usable range of class A as 1 to 126. Then class B ranges from 128 to 191. And the complete range is usable. Similarly, class C ranges from 192 to 223. Class D ranges from 224 to 239. And class E ranges from 240 to 255. Clear, guys? Now, out of the 5 classes, only 3 classes are used for public use, which are class A, class B, and class C. So if anyone wants to set some IP address on their network and they reach out to ISP, so it is a possibility that they'll get the IP only from these 3 classes as they were only made available for public use. Class E is reserved for multicasting. Remember, yesterday we have spoken about a type of communication, which is multicasting, right? So to enable that type of communication between devices, we have class D reserved, which is for multicasting. Class E is also reserved, and it was reserved for research and development. Okay, so as users, we are only allowed to work with these three classes, class A, class B, and class C. I have a question to you guys. Why do you think we are stopping at 255? Why is it just 255, not 256, not 257? I mean, not 300, not 1000. What made us stop at 255? Can you guys tell me? Perfect. As we have the number of bits in one octet as 8, we cannot go beyond 255. Let's understand why. When we speak about the 8 bits, every bit will have a value. Let's see. To find out the value for 8 bits, you can remember or memorize this master formula, which is 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 4, 5, 6, and 7. Another question here for you guys. Why is it only 2 raised to the power 0? Why is it not 3 raised to the power 0, 4 raised to the power 0, or so on? Why is it just 2? Any guesses? I mean, why do we have the base as 2, not any other number? Perfect, because we just have two binaries here or in the computer system, which is 0 and 1. So as we have the base numbers 2 in number, that's why we consider it as the power of 2. So the very first value is going to be 1. This is going to be 2. This is going to be 4. This is going to be 8, 16, 32, 64, and 128. Now, if I keep all the bits as off, which means if I consider 0 for all of my bits, what will be the outcome? So 0, 0, 0, 0, 0, 0, 0. The value which I'll get is going to be 0. So the minimum value that I can obtain from these bits is 0. And what will be the maximum value which I can obtain? 1, 1, 1, 1, 1, 1, 1. Let's try to add this. 1 plus 2, that's 3, right? 3 plus 4, 7. 7 plus 8, 15. 15 plus 16, that's going to be 31. 31 plus 32, 63. 63 plus 64, 127. 127 plus 128, that will be 255. So what is the maximum that I can get out of my 8 bits? It's going to be 255. That is why my class ranges starts from 0 and ends at 255. That's why it is not 300 or 1000 or 500 or anything else. It's just 255. Any questions or doubts so far? Okay. Anuj, if you are facing some difficulty, you can try to join the session again, because I think others are not experiencing any lag in my voice, right? Is my voice clear, guys? Can you confirm? Okay. All right, cool, perfect. Now the question is that what value helps me identify to which class my IP belongs to. Like I took one example here, 192.168.5.10. How do we identify to which class does this IP belongs to? We can identify that by looking at the value of first octet. We have to figure out in which range out of these three classes does 192 falls in. Can I say it belongs to class C? So that's a class C IP address for us. Similarly, quickly tell me, what do you think 150.10.1.56? Which class does this IP belongs to? Class B. Perfect. Why? Because the first octet, which is 150, falls in the range of class B. Now, memorizing these ranges are quite important as a CCNA candidate. I mean, if you are learning CCNA, memorizing this is quite really important. So I'll give you 2 minutes to quickly have a good understanding of all the ranges which are available here. Read this, try memorizing them, and then we will continue in 2 minutes. Okay, someone has a question. Some material mentions the class A range as 0 to 127 and some mention it as 1 to 126. The complete range is actually 0 to 127 only, but the usable range is 1 to 126. So if the question is about defining the usable range, you have to be cautious and type down 1 to 126. Otherwise, the range of class A is 0 to 127. No, Nicholas, for the other classes, whatever is mentioned, that is the usable range. Class B is completely usable, 128 to 191. Similarly, class C is also completely usable, 192 to 223. It is just the class A, which has 0 and 127 reserved for certain users. Loopback IP is a IP address which we use for checking connectivity with the, you can say, device network model. So TCP/IP is a concept which we will be speaking about later on. So to check the reachability with itself, we can say the loopback IP is what we use. It's the local host IP. So you can consider it as an IP which is used by the PC to check the self connectivity. Yeah. Okay, I think we are good to move ahead. Now we are going to learn about how a dotted decimal form of IP address can be translated into the binary form. We just have discussed that PCs or the network devices understand values or data in the form of zeros and ones, right? So that's the binary form. We will try to understand how we can convert a given IP address into its binary form. Okay. Okay, we have a question from Hari that how these ranges are being set. These are defined by the organization itself. Like it is not us who are deciding that the ranges will look like this. It is how the IP version 4 was introduced. Now, if you have a question that how to memorize this or how these values are being considered, then I can help you with a understanding here that the very first range ends at 127, right? So it's pretty obvious that the next one will begin from 128. So you can try just memorizing the last numbers, okay? And the starting one will automatically be understood by. That's going to help you in memorizing this easily. And like I said, it's pretty important to memorize and understand these classes quite well before you get into networking. All right, moving ahead, let's understand how we can convert a IP address into its binary form. To convert an IP into its binary form, we again require the master formula, which starts from 2 raised to the power 0 and ends at 2 raised to the power 7. One, 2, 4, 8, 16, 32, 64, 128. Let's assume that we have got an IP 192.168.10.1, and we have to translate this IP address into its binary form. So let's see how we can do that. First, we'll begin from the first octet. What is the value for first octet here? It's 192, right? So we need to find out the nearest value to 192. What is the nearest value to 192 out of all these values? It is 128, correct? So simply, if the nearest value is less than 192 or the value that we have in our octet, we will turn that bit as on. Now understand this, that out of 192, you have considered 128. So how much are you left with? You are left with 64. So you need 64 more to complete 192. I'll turn the 64 bit also as on. And now if I add them, if I consider these two values, I'll get the outcome as 192, right? So I can keep the remaining bits as off. And this is simply the binary conversion of 192. Easy, right? Any questions in this? Okay. Next value is 168. So again, the nearest value to 168 is 128. So I'll consider it. And then I'll check how much am I left with. Out of 168, I'll subtract 128. I get 40. So for 40, the nearest value is 32. So I'm going to keep it as 1. Now I have taken 32 out of it, we are left with 8. The nearest value is 8. So that's simply the binary version of your value 168. Now for 10, the nearest value is 8. If I subtract 8 out of 10, I'll get 2. So I'll keep 2 also as on and the remaining bits as off. 0, 0, 0, 0, 0. Finally, we have 1, 0, 0, 0, 0, 0, 0, 0, 1. So we can say, as per the outcome here, that the binary form of my provided IP address is going to be 11000000 dot 1010100 dot 4 times 0 1 triple 0, sorry, 4 times 0 1 0 1 0, and then 7 times 0 and 1. Is that clear to everyone? Sure, I will repeat it with another example. Let's have a quick look again to some conversion of IP address. Now we'll use a different IP. Let's assume 200.10.58.76 is my IP address. Very first thing that I need to get started is I need the master formula. So 2 raised to the power 0, 2 raised to the power 1, 2, 3, 4, 5, 6, and 7. 1, 2, 4, 8, 16, 32, 64, and the value for 2 raised to the power 7 is 128, right? The very first value that we'll try to convert is 200. For 200, if I look at the nearest possible value, it's 128, correct? So I'll say 128. Out of 200, if I subtract 128, I'll be left with 2, 7, and 0. 72 basically. For 72, what is the nearest possible value? It is 64. So I'll keep this one also as on. Now out of 72, I have considered 64. What am I left with? I'm left with 8. Do I have a nearest value to 8? Yes, it is directly 8. So I can keep this bit also as on and the remaining ones as off. That's the binary form of 200. Clear, guys? Great. What's the next value? Next value is 10. What is the nearest value to 10? It is 8 in my table. So 0, 0, 0, 0, 1. After I have considered 8 out of 10, I am left with 2, correct? So 0, 1, and then finally 0. That's your binary of 10. Next, I have 58. Quickly let me know what is the nearest possible value for 58. 32, right? Although the nearest value is 64 as per the logic, but because we want something less than that so that we can calculate the bits, we'll go for 32. We cannot exceed the required value, right? So 32 will be on. After I subtract 32 from 58, I am left with 16, right? So 16 is there directly available as a bit. We'll directly say 0, 0, 1, 1, 0, 0, 0, 0. And the value will be 58. Why we cannot consider 64? We cannot consider 64 directly because 64 is greater than 58. I need to find out a combination of bits which comes out as 58, right? So I need to find what is the nearest value as well as a value less than the required value so that I can continue with the calculation. Is that clear, Mahi? Okay, let's move ahead. Let's try to find it out for 76. Guys, I see some of you are mentioning for 58, we have to use 32 plus 16 plus 8 plus 2. No, that's incorrect. For 58, we will only need 32 plus 16. What is 32 plus 16? Oh, that's 48. I'm so sorry. My bad. Yeah, you are right. For 58, it should be 58 minus 32 is going to give me 6 and 2, 26 actually. So for 26, the nearest value is 16. And if I subtract that, I'm still left with 10, for which I can consider 8 plus 2, right? So it's going to be 0, 0, 1, 1, 0, 0, triple 1, 0, 1, 0. I hope that's clear to everyone. Okay. Then the last value is 76. 76 has the nearest value as 64, right? So let's do the calculation. 76 minus 64, 12. So first of all, I'll consider 64. And now I have to find out 12. 12 has the nearest value as 8. So I'll subtract 8. I'm left with 4. So that means 0, 1, 0, 0, 1. And for 4 also I have a direct bit. I'll consider it as 1 and then 0, 0. That's my binary form of 76. Any questions or doubts in this? We'll look at one more example and then I'll give you some questions to try. From we cannot go to a greater value. Understand, if the requirement is, let's say 12, then you cannot consider 16 for it, right? I want a number which can bring out the outcome as 12. I cannot go for 16. I'll make you clear about this with this another example. Let's say we are provided with the IP 172.18.21. Okay. First of all, I'll write the master formula 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, and 7. This is going to be 1, 2, 4, 8, 16, 32, 64, 128. The very first one is 172. So for 172, I have nearest value as 128. 172 minus 128. I'll consider it as 1. And I am now left with 4, 4, 44, correct? For 44, what is the nearest and smaller value? It's 32. So I'll consider it as 1 and subtract it. I'm left with 12. For 12, a value which is nearest to me would be either 16 or 8. But can I go for 16? I cannot, because that will increase my required number. That's basically higher than the number that I want. I want the number as 172. I cannot increase it, right? That's a part of my question. I cannot change that number. So I'll keep it as 8. I'll consider 8. Subtract that, we'll get 4. For 4, I can go for simply the bit having the value as 4 and then 0, 0. That's your binary conversion of 172. Are we clear, guys? Okay. Let's look at the next value. The next value which we have to get converted is 16. For 16, we have a direct bit, so no need to any subtraction or addition, just turn this bit as on and then you are good. The remaining ones will be off. Next is 18. 18 is simply 16 plus 2, correct? So 16 plus 2 and the remaining ones as off. That's going to be 18. Now 21. If you apply the simple logic, simple maths, 18 plus 3 is 21, right? So first I'll make 18. What was 18? 16 plus 2, right? Now for breaking down 21, instead of considering the second bit, what I'll do is I'll again do subtraction. Out of 21, I have considered 16. What am I left with? I'm left with 5. So 5 can be simply 4 plus 1, right? So 0, 4, and 1. That's your binary conversion for 21. Questions or doubts in this? Would you like to try some by yourself? Yeah, perfect. So let's see. I'll give you some questions to try. Try converting them into binary and then we'll talk about their solution. Try to convert all the 5 IP addresses into its binary form and then only at the end put the final result in the Telegram group. Okay. So convert all of them into binary, write the binary version of all of them into a message, and then only share at the end. Okay. And then finally, after you guys are done, we will discuss the solution here on my screen so that we can verify your answers. Take your time, try the same, and let me know once you're done. Okay, I'll give you 5 more minutes to try completing this, and then we will discuss the solution here on my screen. All right, I'm hoping that everyone must have completed the conversion by now. Let's have a look on the solution. The very first IP we have got is 200, 172, 64, 85. So let's try converting it into its binary form. First of all, I'll write the master formula where I'll start from 2 raised to the power 0, 2 raised to the power 1, and 7. This will be 1, this will be 2, 4, 8, 16, 32, 64, and 128. First, I have to do the conversion for 200. For 200, I'll take 128 plus 64. That gives me 192. 192 plus 8 is 200. So 1100, 1000. Then we have 172. So 128 plus 32, 160. 160 plus 8, 168. 168 plus 4 is 172. Then we have 64. We have a direct bit for that. So 0, 1, and all zeros. And finally, we have 85. So 0, 1, 64. 64 plus 16 is 80. 80 plus 4 is 84. 84 plus 1 is 85. So the binary conversion of the first IP is going to look something like this: 11, 00, 1000, dot 1010 1100, then dot 01 6 times 0, dot 01010101. You guys can verify your answers, and if there is any questions or doubts, you can let me know. Otherwise, we'll jump on to the next solution. And if you did it correctly, then good job. Clap yourself, and we'll move to the next one. Okay. The next one is 10.57.1.96. For 10, I'll simply take 8 plus 2. So 4 times 0, 1010. After that, we have 57. 32 plus 16 is 48. 48 plus 8 is 56. 56 plus 1 is 57. Then we have dot 1, dot 96. For 1, it's quite simple. We have a direct bit. So 7 times 0 and then 1. And lastly, we have 96, right? For 96, I'll take 64. 64 plus 32, that's 96. The binary conversion of IP address will look something like this: 4 times 0, 1010, dot 00, 111, 001, dot 7 times 0, 1, dot 011, and then 00, 000. That's the binary form of second IP address. Check your calculation and see if you were correct or not. All right, let's look at the next one. Third IP is 58.176.201.198. The first value is 58. So for 58, I'll take 32. 32 plus 16 is 48. 48 plus 8 is 56. 56 plus 2, 58. Then 176. So 128. 128 plus 32, 160. 160 plus 16 is 176. Then we have 201. 128 plus 64, 192. 192 plus 8, 200. 200 plus 1, 201. Then finally 198. So 128 plus 64 is 192. 192 plus 4 is 196. 196 plus 2 is 198. So 11100000. The binary form of the IP address is going to be 00111010 dot 101 1 4 times 0 dot 11001001 dot 11000010. Cross check your answers and let me know if you were correct by clapping for yourself. Awesome, that's great. I can see a lot of you were right. I'm also looking through your responses, but yeah, I also recommend you guys to verify it by yourself. And if there is any questions or any confusions, you can ask me. I can explain that part again. Third IP is 1.289.49. Let's see. For the very first value, 1, we have a simple direct bit. So we'll keep that as 1 and the remaining ones as 0, 0, 0, 0. Right? Then after that, we have 200. For 200, we'll take 128 plus 64. That's 192. 192 plus 8 is 200. So 111001 and then 000. Then we have 89. For 89, I'll take 64. 64 plus 16 is 80. 80 plus 8 is 88. 88 plus 1 is 89. Then we have 49. 49, 0. 32 plus 16 is 48. 48 plus 1, 49. That's the binary form of the IP address. 7 times 0, 1, 1100, 1000 dot 0101 1001 dot 0011 0001. Perfect. Let's look at the last one then. The last one is 57.85.73.106. For 57, we'll take 32 plus 16, 48. 48 plus 8 is 56. And then 1, that's 57. 85. 64. 64 plus 16 is 80. 80 plus 4 is 84. 84 plus 1 is 85. After that, 73. So 64. 64 plus 8 is 72. 72 plus 1 is 73. Finally, 106. 64 plus 32 is 96. 96 plus 8 is 104. 104 plus 2 is 106. The binary form of the IP will be 00111101 dot 01010101 dot 01001001 dot 011011010. Cross check your answers and see if you were correct. All right, good job to all of you. If you were able to solve these questions correctly, this is how you can convert your dotted decimal form into its binary form. Now we have paid a good amount of attention to this, right? There is a reason behind it. When you get well versed with all these values, all the values of your master formula, when you are able to understand how these bits work, you will be able to perform subnetting really well. So when we'll discuss the subnetting questions, you will be able to understand and calculate things easily because you have practiced it well here in the binary conversions. Okay. So we'll speak about it. We'll try understanding what are the subnet masks and how these different classes offer different size of the networks. But before that, let's take a short 15 minutes break and then be back to continue the discussion. So I'll see you guys in 15 minutes and then we shall continue the discussion about the further topics. All right, shall we continue, guys? Perfect. So before the break, we have learned that there are 5 classes, and we tried understanding that how a given IP address can be converted from its dotted decimal form to its binary form, right? Now, let's continue and let's understand something about public and private IP addresses. So when we talk about IP addresses, there are 2 types of IP addresses: public IP addresses and private IP addresses. The public IP addresses are provided by the organization INA. And these are, like we discussed, these are first allotted to the regional internet registries. Then from there, it goes to ISP, and from ISP, it finally reaches to the customers. Whereas private IP addresses are provided by the network admin. Public IP addresses are paid. You have to pay money to use them. Private IP addresses are free to use. Okay. Public IP addresses are something that can allow me to communicate over internet, and private IP addresses are free to use and can only be used in local area networks. Okay. In the small local networks, you can use them to connect devices, but you cannot communicate over internet. Private IP addresses are reserved from each and every class. So from class A, the address space starting from 10.0.0.0 to 10.255.255.255. These are the private IP addresses which can be used for free. So any IP that falls into this range starting from 10.0.0.0 to 10.255.255.255 is going to be considered as a private IP. Similarly, from class B, the IP starting from 172.16.0.0 up to 172.31.255.255. These are the private IPs. Okay. Then from class C, 192.168.0.0 to 192.168.255.255. These are the private IP addresses. Clear? Now I want you guys to try something. If you are on Windows, you have to open command prompt and type down the command ipconfig. And if you are on Mac, open your terminal and type down the command ifconfig. And try to check what IP do you have on your system. Let me know if that IP belongs to one of these 3 ranges or not. So if that IP that you have on your PC belongs to one of these 3 ranges, that simply means it is a private IP. And if it is a private IP, then how come you are able to use internet? Any idea on that? Perfect. That's because of NAT. Let's understand how it helps. Now in my home, there are multiple devices, right? There is a laptop, then there is a tab, there is my mobile phone, then I have a smartwatch. All these devices will be connected with each other on a private IP network. But whenever they want to speak on internet, they need a public IP, for which I have taken an Airtel connection, which assigns a public IP on the outgoing interface of my router. There's a home router, the Wi-Fi router, which basically connects with all these devices over radio frequencies, right? And that's configured with a public IP on the outgoing interface. Now, whenever these devices would like to communicate with internet, my private IP will get translated to public IP. And this process of translation is called network address translation, which stands for, which is NAT. Now, how do we configure it? How do we use it? Or what are the different types of NAT? That's something we are going to learn later on in our training. As of now, I wanted to tell you about this technology. Okay. The reason why we use NAT is simply to preserve public IP addresses. Okay. So we want to save our public IP addresses, first of all, because we pay money for that. We can't simply waste anything that we are paying money for. Secondly, there are only limited public IP addresses which are available. So, which is also the reason now we have switched to IPv6 as we are out of the public IP addresses in IP version 4. So every network requires, or every network engineer wants to ensure that they do not waste any public IP. To make sure that they do not waste any public IP, what we consider is implementing something called as subnetting. Make sense? What is subnetting now? Subnetting is basically trimming the network in a manner that it can fulfill my requirement and can avoid wastage of IP addresses. I'll show you how this works. Every class of IP address has certain network bits and certain host bits. So every network, I can say, or any network is divided in two parts, network part and host part. So we discussed that we can only use class A, class B, and class C, right? For class A, the range is from 0 to 127. Class B, the range is 128 to 191. And for class C, the range is 192 to 223, right? Like I said, every network will have a network part and a host part. What is the total size of IP addresses, guys? 32 bits, right? So in a class A network, by default, the network bits are 8 and host bits are 24. Clear? Similarly, by default, a class B distributes the network and host bits as 16 and 16. Class C distributes it with 24 in the network part and 8 in the host part. Make sense? The number of host bits defines how many addresses a network would contain if we use it. Okay. So the number of addresses a network might provide can be calculated by using a formula which is 2 raised to the power host bits. So if I have taken a network from class A, how many host bits do we have there? 24, right? So to calculate the number of IP addresses that my class A network would provide, I have to find out the value of 2 raised to the power 24. Correct, guys? Similarly, to find out how many IP addresses my class B network provides, I have to find out the value of 2 raised to the power 16 and then 2 raised to the power 8. 2 raised to the power 8 is 256. So a class C network provides me how many IP addresses? 256. 2 raised to the power 16 is 65,536. If I have taken a class B network, I can assign IP addresses to 65,536 devices and can put them in same network. And if I talk about class A now, it's going to be more than 16 millions. So class A network is capable of providing IP addresses to how many users? 16 millions. Make sense? Now in a network, the network bits or the network part is represented with 1 and the host part is represented with 0. So for class A, we have understood that there are how many network bits? 24. And how many host bits? 8. If I write it down in binary, it's going to be 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22. Oh, oops. I made a mistake there. It is for class C. Yeah, it is for class C. 24 in the network and 8 in the host part. So like we discussed, 24 in the network, 8 in the host part. So the 24 network bits will be represented like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24 dot. Now the host bits 1, 2, 3, 4, 5, 6, 7, 8. Correct? This is the binary form of my network and host bits distribution. Correct? We have understood how to convert the dotted decimal form into binary. Can you guys try doing the reverse and let me know what will be the outcome of this in the dotted decimal form? So for all the bits which are on, if I use my master formula, 2 raised to the power 0, 1, 2, 3, 4, 5, 6, and 7. This is 1, this is 2, this is 4, this is 8, 16, 32, 64, and 128. If I keep all of them as on, what's going to be the outcome? Will be 255. So for my first octet, the value will be 255. For my second octet also, it's all 1. So it will be 255 again. And for my third one also, it will be 255. Final one is all zeros. So very simply, I can understand the outcome will be 0, right? Guys, this representation of network and host bits in dotted decimal form is called as subnet mask. What do we call this? So for class C, the subnet mask is going to be 255.255.255.0. Let me write it down here. The subnet mask for class C will be 255.255.255.0. A subnet mask is nothing but a representation of network and host bits distribution. Like if I have to tell my router what is the network bits and what is the host bits in a network, I can tell it using the subnet mask. Okay. So it's just a way of defining which portion of your network is the network bits and which portion is the host bits. Similarly, we will try it now for class B. For class B, we have the distribution as network bits 16 and host bits 16. So if I write it down in binary, it will be 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16, 0, 0, 0, 0, 0, 0, 0, 0, and then again 8 times zeros. This will be 255. This will be 255. This will be 0. This will be 0. That's my subnet mask for class B. Quickly let me know, what do you think will be the subnet mask for class A? Awesome, good job. 255.0.0.0. Why so? Because a class A network will have 8 bits in the network part and 24 bits in the host part, making the binary as 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this will be 255, this will be 0, this will be 0, this will be 0. And that's your subnet mask for class A network. Let me know if there is any doubts or queries so far regarding whatever discussions we have had. How to take 1 or 0 for class ABC? No, we don't decide how to take it. It is defined already that the network bits will be represented with 1 in a subnet mask and host bits will be represented with 0. And this is the distribution by default defined for all the three classes. For class A, it is defined already that 8 bits will be in the network part and remaining 24 bits will be in the host part. 16 and 16 is the distribution for class B. 24 bits in the network and 8 bits in the host part is what we have got for class C. Keeping that in mind, what we did, we simply wrote them in the form of 1 and 0. Because I had 24 bits as network in the class C, so what I did, I added 24 times 1 and then 8 times 0. Converted it into dotted decimal form and it gave me my subnet mask. That's what I have done for class B and class A also. Class D and class E are not something that we use. So that's why those classes are reserved. We don't have any explanation on them or any understanding about network and host routes. We don't basically have to get there. Those are reserved. We cannot use them. All right. I have one more thing today to explain you and then we are good for the day. We have understood how the network and host bits distribution works. Now, this will also help us in understanding how I can understand if two devices belong to same network or if they belong to different network. Every network address can be represented with a value called CIDR value. CIDR stands for classless inter-domain routing, and a value which we use with it is a slash value. For example, for a class A network, I will use the value as /8. For a class B, I'll use /16. For class C, /24. Why so? Because the value after the slash represents the network bits of that particular IP network. Okay, so if it is a class A network, by default, how many network bits do we have there? 8. So I can say a /8 is the representation of this subnet mask in a simpler form. Similarly, /16 is a representation of this subnet mask in a simpler form, and /24 for this one. Clear? Now, assume that you have PCA connected to PCB. On PCA, the network configured or the IP configured as 192.168.1.5/24. On PCB, it is 192.168.1.10/24. Now the question is, do they belong to same network or not? Okay. So I can say two IPs belong to same network if network portion has the same values on both sides. Same values on both IP addresses. So let's see what is the network portion here. In this case, we have said how many bits do we have in the network part? 24. According to which the first octet will be of network, second octet will be of network, third of network, last for host. Network, 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 sorry, network, 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 host. Correct? Check both the IP addresses and let me know if the network portion on both the sides are same or not. Is it same? Yes or no? Yes, they are same, right? That simply means they belong to same network. And if I make a direct connection between them, they'll be able to communicate. Similarly, assume that your first PC has the IP 150.1.5/16 connected to 150.10.20.5/16. Do you think they will communicate with each other? Perfect. As most of you have mentioned, yes, they will communicate with each other because they belong to same network. And how can I say that? Because they both are /16 networks. That means only the first two octets are part of the uh, network portion or are belonging to the network portion. And if I compare on both the sides, the first two octets have same value. That means yes, they will be able to speak with each other. Okay, another one. 10.5.6.1/24 connected to 10.8.6.10/24. What do you think? Some of you are saying yes, some of you are saying no. This is quite an interesting one, isn't it? Okay, let's see. What do we think about it? Are they same network? Option number one, yes. Option number two, no. I have created a poll. Let me know. Put down your votes there and let's see how many of you think they belong to the same network and how many of you think they belong to the different network. Try to respond to the poll. I can see only 22 votes. Let's make it interactive. Okay. 40% of you think yes, 60% of you think no. Okay, let's try to figure out, do they belong to same network or not? If I talk about the class of this IP network, it's class A. But if you might have observed, every time I was talking about the network and host bits distribution, I was using the term default before it, right? I was saying it is the default distribution of network and host bits. Does that mean that I can play with that distribution? I can change that distribution? Yes, we can do that. And if you see here, I have mentioned /24. According to /24, how many octets are going to be of network part? The first 3 octets, right? This is going to be the network part on both the sides, and the last octet is going to be the host part. So do we have the same value in the network part? No. Does that mean they belong to different networks? Yes. So they will not communicate with each other if they are directly connected, as they belong to different networks. So we don't always have to just look at the class. We have to look at the value which is provided next to it, and then understand if the two IPs belong to same network or different network. Is that clear, guys? Another one, 192.168.5.1 is my first PC, and second PC is 192.168.4.20. What do you think? Will they communicate with each other? Okay, most of you tried to answer it. Most of you said yes. Some of you said no. I didn't specify any slash value this time, right? So when you are not provided with slash value, what you do is you use the default slash values. Like I said earlier also, those are the default slash values. So if now I am not provided with any information, I'll consider the default value as the slash value for these networks. Because they belong to class C, I'll consider the default slash value as 24. According to /24, do you think they belong to same network or different network? Different networks. Perfect. So will they communicate with each other directly? No. In such a scenario, when we have different networks, we have discussed earlier that there is a device which we use for connecting them. What is that device? When we were speaking earlier about the different network devices, we spoke about one device which can connect different networks together. Can you recall what was the name of that device? Router. Perfect. So it's a router which we can use for connecting different networks together. And that's all for today. That's what I wanted you guys to understand today. Tomorrow in the session, we will talk more about subnetting. We will understand how things like this can be calculated, right? We'll try to break down bigger networks into smaller parts. We'll talk about subnetting, learn how, according to my requirement, I can uh, create chunks out of my bigger network and use them for the appropriate usage and not wasting my IP addresses. That your day ahead. Bye, guys. Thank you.